Right, so you should be on page 107 of your workbooks, and if I was in class doing this with you, I would have you guys work on this on your own in your groups or in your partners, and then check your answers. So it might be smart for you to pause the video and go through this and see if you can do it, and then obviously play the video again and make sure that you get it correct. So this says an ice skating rink manager tracks each day's revenue R based on an hourly daily fee F for skating using the function R of F equals negative 480 F squared plus 3,120 F. So this says what hourly fee, so that's your F, which you can tell from the function is really like your X, will produce the maximum revenue. So as soon as you see maximum, hopefully you're thinking vertex, because remember maximum and minimum, those words are associated with the vertex. So to find the X of the vertex in standard form, which is what we're given, you have X equals the opposite of B, so negative 3,120 divided by 2A, which is 2 times negative 480. Okay. Again, like I've been talking about the past couple days and really all semester, make sure that you um, clean that up first. And you get negative 3,120 all over negative 960. So when you calculate that, you should get 3.25. So think about the context of the problem. The context is saying what hourly fee will produce the maximum revenue, so that's in dollars. So your answer would be $3.25 is your hourly fee. So then the next part says, what's the maximum revenue the manager should expect? Well, the revenue is your R, which is your Y, because it's R of F. So what you're going to do is take that 325, figure out, okay, well, the revenue when it's $3.25 an hour should be negative 480 times 3.25 squared plus 3,120 times 3.25, right? Put that in your calculator as is with parentheses. And you should get the revenue, which is $5,070. So the max revenue that the skating rink can make is $5,070. Okay, so that's just using opposite of B over 2A and then substituting back in because you're in standard form. So what we're going to do today, again, you guys, just like we've been talking about, this isn't anything new. We're just revisiting the same information and maybe making new connections, but you're not actually learning new mathematical skills. Especially here on example number 1 on page 109. It says, given the quadratic function here, which, if you notice, that, hopefully you're noticing, is vertex form. This just says identify the vertex and determine whether it's a minimum or a maximum. It's in vertex form, guys. This is H, this is K. The only thing you need to remember is that it's the opposite of H, so your vertex is negative 6, because it's x plus 6, so negative 6, and then negative 2. So that's my vertex. The next question is it a maximum or a minimum? Well, your A value here is that 1/2, so A is a positive 1/2. Since A is positive, that means my graph is opening, maybe, there we go, up, because A is positive. So that means your vertex is going to be down here, so it is a minimum. Again, literally nothing new. That was totally a review from last semester. So go ahead and turn to page 110. Example number 2 says, there we go. Determine the equation of a quadratic function that has a minimum. As soon as you see minimum, you should be thinking, oh, that's my vertex. So as soon as you see vertex, you get H and K, and passes through the point -2, -5. Well, any point is X y. Again, you guys, it's not saying what form they want it in. So as soon as you're given the vertex and a point, you should be thinking, oh, I'm going to use a vertex form. Well, I have hk and x and y, so we need to substitute in to find a. So I always write out y equals a times x minus h squared plus k. It helps me to see the actual standard form and know what to substitute in where. My y is -5. I'm looking for a. My x is -2 minus h, which is minus a -4, so that's why that looks like a plus, squared, and then plus k, which would be plus -8, so -8. So again, you guys remember, this is all stuck together because of order of operations. So you get -5 equals, well, -2 plus 4 is 2, right? 2 squared is 4, so you end up with 4a minus 8. So we're going to add 8 to both sides, and we get -5 plus 8 is 3 equals 4a. Divide both sides by 4, so I'm running into example 3 here. So a is 3/4. So like we talked about before, when you're actually going to write the equation, you only want x and y as your variables. So we have y equals our a value, which is 3/4, times x minus a -4 for x minus h squared plus k, so plus a -8, which is really -8. And that's your actual answer. Now, example number 3, I'm going to show you 2 ways of doing example number 3. So we talked about this yesterday in class. Pay attention to what example or which way I want you to do it, but both are possible. Okay, here it says convert the function g of x equals -7x squared plus 14x to vertex form. Well, this is in standard form right now. So the 2 ways to do that, the first way is to complete the square. Now, we completed the square before when we were solving, and this was 0. Now it's going, I always change it and say, okay, well, g of x is the same thing as y equals -7x squared plus 14x. Now, when you're completing the square here, a couple things we want to remember. First thing, you want to get that a out of there, so -7 is the only thing you take out, and then you have x squared. A lot of people forget this. 14 divided by -7 is -2x. Okay, so once you factored out your a, now you're going to add in your blanks. So this is normally like 0 or a number plus a blank. Now it's just going to be y plus a blank equals -7 times x squared minus 2x plus a blank. So remember, in the blanks, you're going to take that -2, divide it by 2. So -2 divided by 2 is -1. -1 squared is a +1. But we didn't just add 1. We added 1 times -7. So -7 goes over in the blank. So we end up with y minus 7 equals -7 times, this whole thing condenses. Remember, that's really x minus 1 times x minus 1. So you have y minus 7 equals -7 times x minus 1 squared. Well, if you think about what standard form looks like, which we did up here in red, we have our a part right here. We have the x minus h squared part. But if you notice in standard form, y is by itself. So the last thing you need to do is add 7 to both sides. And you get y equals -7 times x minus 1 squared plus 7. And that's your answer in vertex form. So that's completing the square. And so all that I did there, the only thing that was different from before was instead of that y right there is a y instead of a number. You guys are used to seeing that as a number and then solving. And here we just simplified and got y by itself. Now, the second way of doing this is think about vertex form. What are the 2 things we need for vertex form? Well, we need a vertex and we need an a value. So like we talked about yesterday, the a value is the same no matter what form you're in. Well, this right here, they give us standard form. So that tells me that my a is a value of -7, no matter what form I'm in, and that checks out from when we did it from completing the square. Well, for your vertex, how do you find your vertex in standard form? You do x equals the opposite of b, which in this case is -14, all over 2a, so 2 times -7. And you get -14 all over -14, which is a +1. To find your y, you substitute it back in. So -7 times 1 squared plus 14 times 1. Okay, either do it in your head or pop it in your calculator. It absolutely doesn't matter to me how you do it. And you will get 7. So now we know our vertex is at the point 1, 7, and that's my h and my k. So I can go through and I can sub in my a value and my h and my k. So now I know my standard form is, I'm sorry, it was in standard form. My vertex form is going to be y equals a, which is -7, times x minus h squared plus k. And if you look, it's the exact same answer no matter how you do it, either completing the square or determining what the vertex is using opposite of b over 2a and the a value. Okay, so not new skills. You know how to do completing the square. You know how to do opposite b over 2a and all that jazz. You just need to remember when to do it. So that's converting from standard to vertex. The last thing is sketch a graph of a quadratic function. This is in vertex form, you guys. This is old news. You know how to do this. It says label the vertex, the axis of symmetry, the y-intercept, and one pair of symmetric points. So my vertex here, well, I can just pull HK because it's in vertex form. So my vertex is at -3, -8, which means my axis of symmetry is x equals -3. Okay. Now, your y-intercept here, this is not as easy as just saying, oh, just 0, 8 or 0, -8. Remember, a y-intercept means that you have to set x equal to 0 and solve. So when you're in vertex form, you actually need to do the work for that. So all I did was I took my original equation and I made my x 0. So I get y equals, so 0 plus 3 is 3. 3 squared is 9. 9 minus 8 is 1. So that tells me that my y-intercept is the point 0, 1. And then it says one pair of symmetric points. So if we graph this, we are at -3, -8, 0, 1. All right. No, that's not what I wanted to look like. Let's see. There we go. So we're at -3. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we're at -3, -8. Our axis of symmetry goes through that point. And let's see, we are up here at 0, 1. Okay. Now with our symmetric points, because it says find a pair of symmetric points, here we went 3 to the right, so I'm going to go 3 to the left. Okay, and just for practice, let's find our x-intercept so we know what the graph should look like, right? So for our x-intercepts, that means y is 0. So we have 0 equals x plus 3 squared minus 8. So we can actually solve by taking square roots. So we can add 8 to both sides. And we get 8 equals x plus 3 squared. Square root both sides. And you get plus or minus the square root of 8 equals x plus 3. Subtract 3 from both sides to solve for x, and you get -3 plus or minus the square root of 8 equals x. Well, remember, That's two answers. That's -3 plus the square root of 8 and -3 minus the square root of 8. So to figure out what my x-intercepts are, -3 plus the square root of 8, I'm going to pop that in my calculator. And you get -0.18 or 17. And then -3 minus the square root of 8. And you get -5.83. So your x-intercepts are at -0.17 comma 0 and -5.83 comma 0. So they're ugly, but really your calculator did the ugly work for you. So we're at -0.17, so like right there, and -5.83, so like right there. So your graph looks like that. The other thing you can say is, well, my A value is 1, so since my A value is 1, if I go over 1, I'm going to go up 1. If I go over 1, I'm going to go up 1. If I go over 2, you're going to go up 4 because 2 squared is 4, and so on and so forth. Okay, so that's what that graph looks like. So, again, literally nothing new today at all. Okay, this is probably the newest thing on example number 4 was going through and doing the completing the square with a y instead of a 0. But either way is fine. And then this is just going through and graphing from vertex form, which we've already done. So we're going to skip the problem-based task for now. You can start your homework, which is page 113, number 1 through 10. It's all very straightforward. Check your answers in the back of the book, and we'll go over homework answers tomorrow along with homework answers from last night's homework as well.